Hello again. So, now we are going to start with arguably the easiest of the inequalities to prove. We want to prove that the hypotenuse of a right triangle is longer than each of the two sides of that triangle. So, let's draw a right triangle. Just like this. And label our right angle, and we're going to call the triangle A, B, C. Now, the theorem we know about triangles, the one we've proven, is the Pythagorean theorem, which states that the hypotenuse squared is equal to the length of AB squared plus the length of BC squared. Alright, well, what does that tell us? Well, we know basically, we have to know that AB is greater than 0 and BC is greater than 0, since you cannot have a side length of 0 or a negative number. So logically, we can't have BC being 0 and AB being 0, because then there would be no distance and it would just be AC as a straight line. So we know that AB and BC are positive numbers, and since AC is the value, or AC squared is the value of AB plus BC squared, so since AB squared is greater than 0 and BC squared is greater than 0, then AC squared is the sum of two positive values and is greater than each part of that sum. So what this is saying mathematically is, since this is true, and that since AB squared and BC squared are positive, then we must have that AC squared is strictly greater than AB squared. Because we also know that BC squared is positive, so since AC squared is the value of AB squared plus another positive number, it must be greater. And this also implies that AC is greater than AB. And continuing that logic onward, we have that AC squared is greater than BC squared. Again, because AC squared is BC squared plus this positive value of AB squared. Therefore, that is also implying that AC is strictly greater than BC. And that is the gist of the proof. So we have shown that the value of AC is strictly greater than AB, and AC is strictly greater than BC, meaning that AC is longer or has a greater value than AB and BC, and therefore is the longest side of the triangle.